I'd like to invite Mr. Simon Stephenson. He's going to be talking about NSF and its portfolio of Arctic Ocean research.
Just a sec. Has everyone who's in the back row who wanted a seat taken a seat? Because there's still plenty up here in the second row, third row even. Excellent views. Okay.
We promise we won't bite.
Simon?
Hi, sir.
Thanks.
The middle's laser pointer. Okay. Forward, back. And this shows current slide, next slide, and time.
Okay. All right, so that's me. And I'm going to talk about the NSF portfolio. I'm not going to talk too much about the science results, but just to give you really a flavor of the range of work that NSF supports in the as this symposium considers the impacts of a changing Arctic. Outline Arctic observing is probably where we spend most of our funds on work related to the symposium topic. Some of that work is also focused on processes and just simple discovery, synthesis, putting it together, and as Martin has talked about, we also have a program addressing humans, not just the indigenous community, but also the sort of global community. And then I will briefly talk about a new theme, navigating the new Arctic at NSF. So you can just about make out the ocean portfolio here in the blue on blue coloring. This is the Arctic observing portfolio from 2000, when the program really began. In response to a small workshop that NSF hosted, actually at NSF, encouraging us to create a program of long-term observing. As you see, the atmosphere, ocean, and sea ice make up the bulk of that portfolio, and that's sort of consistently continued through up to the present. And projects do come and go, and I'll talk about both ones that are in the past and currently going on, and some in the future. But the next slide sort of shows the portfolio in terms of number of projects. These are not number of awards, that would be higher because there are collaborative projects. But the number of projects, it's sort of stable around about 20 now. The big jump up after 2011 was actually the stimulus package going into the field. So that was quite a significant ramp up for our observing portfolio. A typical project, I can't talk about them all, but a typical project is the International Arctic Buoy program. This is actually collaboratively funded across the international community, but also I've listed NSF and NOAA, but I think ONR and NASA also provide currently support to the Buoy program. And this has really, been a fantastic program run out of University of Washington, looking primarily at meteorological and oceanography data from the upper ocean, 79 to the present. Our support kicked in somewhere in about 2002. One of my favorite stories about what scientists can do that sometimes the agencies and the international community find, or formal communities find more difficult, is during the IPY, there was a US-funded buoy placed in the ocean by a French research team off a Chinese vessel. And I can't imagine the number of agreements the agencies would have to do to put that into place. But that's what they did just by a few emails. So it's fantastic work. And so that's continuing. They're always looking for funding, and we continue to support that. The North Pole Environmental Observatory was actually our earliest funding from an observing program point of view. In the left, you see the buoy drift map that the team put in. On the right-hand side is the aerial CDD chemistry surveys on a grid pattern that was coordinated not just with the awardees on the North Pole, but also several other awardees looking at the upper ocean chemistry. They're particularly looking at the changing layers, the changing surface oceanography and the atmosphere above it in the central Arctic basin. And one result, this is probably the most sciencey slide I'll show, coming out of that work by Morison and others in Nature, was showing the freshening of the Beaufort Sea. So this is an effort that was particularly focused on an annual airborne hydrographic survey, deployment of drifting buoys, and actually the maintenance of a deep ocean bottom pressure sensor that was used to calibrate satellite data. And this is another aspect, just like the International Buoy program. There's a large interchange between the field programs and the satellite data, and this result was using the satellite data as well. Another long-term observing program is actually building off something run in the biology directorate, and that's the long-term ecological research. So while NSF is famous for its 3 to 5 year grant cycle, back in the 80s, the biology program realized that that you couldn't actually understand ecosystem change in those time cycles. That ecosystem change occurs on longer time cycles, so they transformed the way they supported a piece of their portfolio in long-term ecological research or sites. And Ken Dunton and his team have just put in a proposal, and it's been awarded to look at ecosystem change along 3 sites along the north coast of Alaska, from Katovik over to Barrow. And so they're looking at the drivers, the forcing between the between the ocean drivers and the terrestrial drivers in the food web on the coastal lagoons. And this is critical to understand because the communities along that northern coast are primarily subsistence communities and rely very heavily on the food in those systems. They're also looking at natural cycles and how those are changing the productivity, and also looking at how warming and thawing permafrost, the changes in the sea ice that Martin mentioned with the higher wave heights, how those sorts of other drivers in this changing Arctic are changing the system. I believe the SciSix program was discussed yesterday, but I can't really help not discuss it again, or at least touch on it. The submarine is just an amazing platform, or potentially amazing platform. NSF has been very involved with the Navy since the mid-90s. The phase 1, where scientists were on board, is over. Phase 2, we're in phase 2 now. There are challenges with the program, and I think that came up a little bit yesterday. It's difficult to write a proposal to NSF if you don't know what data you're going to get and when you're going to get it. But it is possible to write a proposal to NSF if you've already got the data. So looking back on the data collection is definitely something that we're interested in doing, just as we did in the 90s with the sea ice draft profiling. So the science community have worked up a science plan, and understanding the difficulties that go along with using a platform that is actually so sensitive in its primary mission. We do encourage the science community and the Navy to continue to make SciSecs available, because it is a truly amazing platform potentially for us. So that's the observing profiles. I'd like to move now to more of the process studies and discovery. And geotraces is a good example of what we expect to be in both of those sort of themes. The goal was to identify processes and quantify fluxes that control the distributions of key trace elements and isotopes. That's from the proposal. What that actually means is you'll take the different trace chemicals coming into the system from the bottom, from the ocean bed, in through the atmosphere and in through the gateways, and by tracking how those traces change, how they interact with the system, you can actually study both processes and also structure of the whole Arctic Ocean, not just the surface now, but the whole water column. And we've learned how to do this in the rest of the ocean in a relatively new set of efforts. But the Arctic remained as one of the last challenges because of the ice cover, of course. So at least 6 countries have gotten together: US, Germany, Canada, Sweden, UK, and Russia as the leads. But other countries were involved in the actual science. So this was a great program in 2015. And the results are still actually being worked up. The picture there on the bottom is the polar stern meeting up with the Healy at the North Pole to close those 2 transects. The US transect is in the red line. The next project on discovery and processes is MOSAIC. So this is to be. It's in 2019 to 2020, freezing the German vessel, the Polar Stern, into the ice pack on the Russian side and watch it drift over. There'll be sort of remote stations, support getting people in and out through ANOVA flights from NASA and the German program. So this is to come. I'm mentioning it in our portfolio because we have decided to support some projects. Alas, we haven't funded them yet. So we haven't yet announced what we're funding. So I can't tell you who's been awarded. There will be a few projects that we will announce in the next month or 2. Some projects will also repropose or propose anew, seeing what the gaps are. And so our portfolio will join the Department of Energy, who have already decided to support atmospheric radiation monitoring with their mobile labs. So that's great. I'm not sure this next slide will actually work, but it shows maybe, yeah, okay. So this is just a sort of cartoon about the many processes that are in play that the Polar Stern will be looking at. This actually began in the atmospheric working group of the International Arctic Science Committee. This working group was relatively newly established, and they went back to first principles of what we don't know, primarily about the atmosphere. Clearly they were interested in its interactions with the ocean and sea ice, but they were really looking at the equations of state for the atmosphere. And that was really the beginning of MOSAIC back in 2011. It's come a long way, and people have sort of built off those initial questions to add in the sea ice, add in the ocean system, and because of the German leadership of this project and their strength in ecosystems, they've put that in too. Because the platform, again, just like the submarines, is such a unique platform. The last time we did this was in Schieber in the late 90s. So all of this data is great. It's coming out. It gets published in the papers. Equally important in our portfolio is the ability to put the pieces together primarily through modeling and other tools of synthesis. And so Andrei Proshutinsky some time ago proposed basically a forum for modelers and observers to get together. And this has become a very popular forum. In fact, he told me the other day he's actually going to have to limit the people going to his fall meeting because it's become so popular. However, the limitation is really just to make sure that the discussion actually happens in a manageable group of people, but the impact and the results they intend to sort of share more through a sort of social media approach. But it's to make sure that the different modeling teams are talking to the observing teams, that they're doing the reanalysis and examining different methods to do so, and exploring the different corrections for initial conditions and boundary conditions. So that's been a very successful tool funded out of the Arctic System Science Program. So I'm going to step now to sort of interactions with the people who live in the Arctic. In the 2000s, say, community-based observing became an important tool. Martin, when he was the program officer for Aeon, the first one, funded NSF's first efforts in community-based monitoring. So that's the bottom piece of this little cartoon, the person on the ground working with satellites and aircraft, and so, but in this sort of rendering, you can see that the people on the ground are supporting a bigger effort, which is often driven by agency needs or scientist needs. Community-based monitoring also can be, and this was actually the first proposal that we supported, community-based monitoring for community needs, and both are okay. And so this is actually a new award to Lilla Lesser. It was funded just in time for the Arctic Science Ministerial, where we were bringing together the different approaches to community-based monitoring, including ones that are driven by agencies, ones that are driven locally, and looking at the best practices across that domain. Another effort funded by the Social Science Program was looking at documenting Indigenous knowledge. And this is really the first step in pulling in communities to work with scientists to produce new knowledge that's driven as much by the community needs as by the scientific needs. This is the term we use is co-production of knowledge. And this is really sort of where I think a lot of our portfolio will, well, actually not maybe a lot of portfolio, but a considerable piece of our portfolio will head at the intersection of science and local needs. And this last slide is an activity led by Paul Berkman and others called Pan-Arctic Options. And this is sort of an example of where the social system, engineers, and policy, and the actual changing natural system all intersect. And so this was funded a couple of years ago, and it's has participation by Canadian, Chinese, French, Norwegian, Russian scientists, along with the US. It was actually funded, I think, by Russian and French funding agencies along with NSF. And so we're very excited about this model. This kind of integration is actually sort of the way we're thinking about this new activity called Navigating the New Arctic. So Navigating the New Arctic started off as a big idea at NSF. There were 10 of them developed last summer at NSF to get the agency to think more integratively across its whole portfolio. And it started really focusing in on the observing part of that scheme. But as I've just illustrated, really the observing has to be driven by the information needs and what you want to really understand. So as we've developed this activity, not just with the Arctic Science section, but with our engineering directorate, with the social science directorate, obviously with geo and biologists, and actually also the computer sciences and technology development parts of NSF. So really almost all of NSF sort of sees a role in understanding the new Arctic, and our hope is that we will be able to move this idea, this big idea, forward across the agency.
Thank you, Simon. Actually, there was one online, thank you. Wipes have been fun. One question, online question, but your last comment actually answered. The question was, you mentioned the Biodirectorate, but are there other significant investments in Arctic research at NSF that are outside of the Office of Polar Programs?
Yeah, so there are. Certainly it's in bio. The social science program in GEO, we do have one, so it's in the Arctic. Has a lot of funding with social science, social, behavioral, and economic sciences is the full name of the directorate. We have had less with engineering. A few years ago, maybe a decade ago, engineers said, you have really interesting issues and problems, but they affect so few people that that's really not where our priority lies. That view has changed as the Arctic has become sort of more of a global problem. People in the engineering directorate have been very interested in participating, and we're getting help from them to sort of frame some of the questions coming out.
Thank you.
Pablo.
Yes.
Simon, I have a quick question.
Give one to your friend.
Oh, my friend?
Yeah.
Simon, that was very interesting. You mentioned the greater integration around NSF on Arctic. That's wonderful to hear. Is there a reallocation of resources across NSF or the directorate to support more Arctic research in the Division of Polar Programs, for example?
No, I don't think so. We're trying to make the case in the sort of typical budget cycle that we have a case to be made, and that's where this big idea is sort of sitting. It's sort of in a formative stage, but I think we can make that case. It depends on what resources the NSF gets and how those get allocated. But I think what's been pleasing is that other directorates are sending their program offices to these navigating meetings and saying, yeah, we see ourselves in this.
Thanks. Let's